Today I want to show you how geometry can sometimes outperform calculus. Let's try a length optimization problem often found in calculus. A 6-foot post is 10 feet from an 8-foot post. What's the shortest rope that connects the tops of both posts while also making contact with the ground somewhere between the posts? Assume you can make the rope straight. Okay, so these are right triangles here. So we're going to let this side be x. And since they're 10 feet apart, this side will be 10 minus x. We know this side is 6, this side is 8. We know that with the Pythagorean Theorem, c squared is equal to a squared plus b squared. So we can say then that c is equal to the square root of a squared plus b squared. So applying that to these two triangles that we have, we can say that the first triangle, the hypotenuse is the square root of x squared plus 6 squared. And on the second triangle, we can say the hypotenuse is equal to the square root of 10 minus x squared plus 8 squared. Okay, let's get started using the calculus method. We'll have to use the chain rule because we basically have a function within a function. So, to give you an example, let's say that y is equal to 2x plus 4. And all this is raised to the third power. Well, I have two functions. I have an inner function and an outer function. I could say then that y could equal the outer function, we'll call this outer function u, to the third power, where u represents the section within the parentheses here. So I could say that u equals 2x plus 4. So think of it as differentiating the outer function first while keeping the inner function unchanged, then multiplying by the derivative of the inner function. And that's basically how the chain rule works. So we could say then that dy dx, let's break it apart into dy over du times du dx. So we could say then that dy du, okay, so let's take this 3 here, just bring it in front, so it'll be 3u, and let's subtract 1, so 3 minus 1 is 2. Alright, so that's the outer function. Now let's take care of the inner function. Say du dx. Okay, so here I'm looking at taking a derivative, so the derivative is 2. So dy dx will be the outer function, 3u squared times 2, which is 3 times u, which is 2x plus 4 to the second power, times 2. 2 times 3 is 6. We can say then that 2x plus 4 squared will be taking the derivative using the chain rule. So this is the approach we're going to use for solving the equations with the triangles. So let's say that the length in terms of x will be equal to the length of the first plus the length of the second. So we can say then that it's the square root of x squared plus 6 squared plus the square root of 10 minus x squared plus 8 squared. Okay, so let's go ahead and expand this a little bit. So this would be x squared plus 36. Okay, if I square 10 minus x, that will give me 100 minus 20x plus x squared plus 64. So x squared plus 36 plus the square root of, rewrite this x squared minus 20x plus 164. Okay, let's get rid of the radicals. So I'm going to say this is x squared plus 36 raised to the 1/2 power. Same thing for the other side. X squared minus 20x plus 164 raised to the 1/2 power. Okay, now we're ready to use our chain rule. Okay, I'm going to do the inner and outers. Okay, so doing the outer first, I'm going to take my 1/2. I'll take that 1/2 over, put it in front. So I'll have 1/2. I'm going to leave some space here. And I'm going to write my x squared plus 36. Now, I got to subtract 1 here, so minus 1. So 1/2 minus 1 is negative 1/2 power. So that's the outer. Okay, for the inner, if I take the derivative of x squared plus 36, I would get 2x. All right, so if I multiply it all out, that will be the first one. Plus, now let's do the second one, same way. I take my 1/2 to the front. So it will be 1/2. I'm going to leave some space. I'm going to write x squared minus 20x plus 164. If I subtract 1 from 1/2, I get negative 1/2. Okay, again, that's the outer. And the inner, if I take the derivative of x squared minus 20 plus 164, I get 2x minus 20. So that would be the inner. Okay, next thing let's do is let's get rid of those negative 1/2 exponents. All right, so to get rid of the negative portion, I send it to the denominator. I take the inverse of it. And to get rid of the half, I would just simply put it back into radical form. So this will equal 1/2 times 2x over the square root of x squared plus 36 plus 1/2 of 2x minus 20 over the square root of x squared minus 20x plus 164. Okay, let's continue with the algebra. So this will be 1/2 of 2x will be simply x over the square root of x squared plus 36. And 1/2 of 2x minus 20 would be x minus 10. Over x squared minus 20x plus 164. Okay, I'm going to set my f sub x equal to 0. All right. So with a 0 here, I'm going to bring this to the other side. So x minus 10 over x squared minus 20x plus 164. And I had to put a negative in front. So that negative makes this negative. This makes this negative. It makes this positive. Okay. And this side is going to remain x over the square root of x squared plus 36. Okay, let's square both sides. So if I were to square both sides, I would get something like, okay, negative x plus 10 squared would be x squared minus 20x plus 100. Okay, I lose the radical here. Something like this. All right, now we want to cross multiply these two. So if I'm cross multiplying, I'll have x squared plus 36 times x squared minus 20x plus 100 is going to equal x squared times x squared minus 20x plus 164. Okay, let's multiply this out. So I would get x to the fourth minus 20x to the third plus 100x squared plus 36x squared minus 720x plus 3600 equals x to the fourth minus 20x to the third plus 164x squared. X to the fourth cancel. Negative 20x to the third cancels. Okay, let's start combining like terms. All right, so adding these two, I get 136 x squared minus 720x plus 3600 equals 164x squared. Okay, I like working with positive numbers, so I'm going to take all of this, I'm going to take it to the other side. So I'd have 164x squared minus 136x squared plus 720x minus 3600 equals 0. So this gives me 28x squared plus 720x minus 3600 equals 0. If I divide this by 4, I would get 7x squared plus 180x minus 900 equals 0. Now we have it in quadratic format. So we're going to say that A is going to equal 7. We're going to say that B equals 180. And we're going to say that C equals negative 900. Negative B plus or minus the square root of B squared minus 4AC all over 2A. So we can say that X then is equal to negative B, which is negative 180 plus or minus, so this would be 180 squared minus 4 times A times C, which is negative 900. All this over 2A. So I can say that X is equal to negative 180 plus or minus. Okay, if I multiply the top all the way out, I would get 57,600. All this divided by 14. So I'm going to say negative 180 plus or minus. Okay, 57,600 is a perfect square. So that'll be 240 over 14. I want a positive distance, so I'm going to be using the plus sign here. So negative 180 plus 240, that's equal to 60 over 14, which is equal to 30 over 7, which is approximately equal to 4.2857. This will be the distance from the 6-foot pole. Because we told it we wanted it that to be x, original equation. Now let's substitute back into the original equation, which was the square root of x squared plus 36 plus square root of 10 minus x squared plus 8 squared, which is 64. All right, so substituting in, so the length of x will equal the square root of 4.2857 squared plus 36. All right, so that'd be 10 minus 4.2857 squared plus 64. So the first one is 7.373. Second equation here is 9.830. So I'm going to add them together. I get 17.20 feet. Okay, this is the length of rope. Okay, let's try the geometry method. All right, so the top of this post here, if I do my XY coordinate system, the top will be at 0x, 6y. The other post here will be at an x value of 10, y will be 8. In geometry and in physics, we often use a classical trick by using reflections. So if I were to reflect the second post here, so by making a reflection, it's the same length, but basically what I'm doing is I'm changing the location of the top. Now it's all pointing toward the bottom. So now my XY position here will be 10, negative 8. So I can use the distance formula between 2 points. Okay, that formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So that will be 10 minus 0 squared, that's my x's, and my y's will be negative 8 minus 6 squared. So 10 squared is 100. 8 minus 8 minus 6 is negative 14. Negative 14 squared will be 196. So this is equal to the square root of 296. Or I could say that would be 2 square roots of 74, which is approximately equal to 17.20 feet. Okay, that will be the length of the rope. That's the same answer we got using the calculus. All right, we can also use the reflection method using triangles to solve for this equation. So if I were to draw the reflection again, okay, so I can make a, let's make a straight line here. And we'll make a line here. So this side is 10. This will be 8 here. 8 plus 6 is 14 combined. We have a right angle. So we can say then that c squared is equal to a squared plus b squared. So that'd be 10 squared plus 14 squared. 100 plus 196. So c squared is equal to 296. C will be equal to the square root of 296. So again, we can say that C is approximately equal to 17.20 feet.